Okay, so the agenda for today's lecture is really twofold. We're going to begin with a basic introduction and motivation to why it is we should want to study quantum mechanics. Then we'll begin to move on to the full, first formal unit of material in the course, which is to understand what are the basic building blocks of the material world around us that we experience every day. There'll be some scientific background I'll have to remind you of that we will be assuming. I won't really be proving this part of it, but that is the existence of atoms. And then we'll move on really to the first piece of material, which is how it is that we know that there are electrons. So let's then begin with the basic introduction to begin off the course. So why should we want to study quantum mechanics? Why quantum mechanics? Well, really, the bottom line here is that we are living right now in a very privileged time in history. It's really only in the last 10 or 20 years that it is finally possible for us to do the following. And that is just simply with the power of the human mind and no experimental input whatsoever other than a few fundamental constants of nature, we are capable now of predicting whatever properties might interest you of any material, even before it's been made in the laboratory. It's really an amazing thing. Now, this ability of us to do this, and we can predict all kinds of things, by the way. You can predict the density of a material, how compressible it is, its bulk modulus, whether it conducts electricity, whether it will be transparent to light. All of these physical properties we can calculate actually to within just a few percent. Now, what makes this possible is a framework for studying the world around us that has a long and storied history. In fact, we right now, you guys, are really living in a time that fulfills a dream of humanity that goes back literally, we can trace it back 2.5 millennia. Back to one of the ancient Greek philosophers known as Empedocles. And he dates to around the middle of the 4th century BC. So somewhere around 450 BC, say, just roughly speaking. We're not, studying history here in this course. But what's very interesting is the idea he had about how we would carry this out. Now, we moderns, sometimes we like to sniff our noses at the ancient Greek philosophers. But over the years, I've really learned to have a lot of respect for these philosophers. Philosophers are really amazing, actually. Right? They're kind of like chess grandmasters. They can see really the big picture. Now, sometimes, yes, the details are kind of off, but certainly we can forgive them that. They didn't have the scientific instruments that we have nowadays to make detailed observations. But they're very good at understanding what would make for an acceptable, coherent, and intelligible description of the world. So here's how Empedocles had set out to do all of this. And you'll see, yes, his details are certainly off, but the overall framework, I hope to convince you, he was right spot on. So for Empedocles, his basic view of how we would understand the material world around us that we experience every day began with some basic data about the world. In fact, the information that there are certain basic constituents that make up the matter around us. Now, these basic constituents that he called elements, and these are the famous four elements that the pre-Socratic Greeks had. These were, of course, the famous earth, air, fire, and of course, water. Now, many of you may be familiar with that idea, but there's something that's a little less familiar to folks, which is he not only knew that we had to understand what the basic elements constructing the world were, we needed to know how they interacted with each other. So not only did he have constituents, he actually had interactions. And he had two distinct types of interactions. And those interactions he called love and strife. And what modern historiographers understand that he meant by these For love, he meant some kind of an attraction. And for strife, he meant some kind of repulsion. Now, his basic program that he recommended then was to understand the basic constituents of the world, to understand the basic interactions among those constituents, and then to use the power of the human mind to reason from this information in order to be able to predict and control the material world around him. And to carry that out, he had a certain method which he employed, and his method, of course, was the method of philosophical dialogue. Basically, simply discussing through what makes logical sense, what implies, what premises imply which conclusions. Now, we, as I have said, have only in the last couple of decades been able to fulfill this dream. And the interesting thing is the way that we do it follows exactly Empedocles' program. So this is now the modern science's view of how we can carry out his program. And you'll see the structure is actually literally exactly the same. What is different are simply the ingredients. So in terms of the constituents of matter, it turns out that we don't need these four constituents. There are only actually two that we need to consider. And by using these two, we can predict those material properties to within just like about 1 or 2%. And those constituents that we need, those two basic constituents, are the electrons and nuclei. Now, the interesting thing is, to make these 1% material predictions, you actually don't need to know the details of what is going on inside the nucleus. You don't need to know that there are protons and neutrons and quarks and gluons and all of that great stuff that's going on inside of there. You can simply treat the nucleus as a given point with a given amount of mass and a given amount of charge. Okay, next. Now, in terms of interactions, it turns out that although there are four fundamental interactions in nature, we actually only need one part of one of those interactions to make these highly accurate predictions. Right? We've got the strong and nuclear force, but as we just said, we don't need to know what's going on inside the nucleus. We can simply take it as given. You then have gravity, which is a fairly weak force, and also it's fairly simple in how it acts. Just bodies of masses we know attract each other. You've mastered the physics of that in your introductory physics course. But the effects of gravity have very, very little impact in terms of how materials behave, how chemicals combine, how the material stuff around us works. In fact, all the materials that are in the space station work just as well on the space station as on the Earth's surface. So gravity is not really what's important. What is important is the remaining fundamental interaction, which is, of course, the electromagnetic interaction, E&M. And of all those interactions, it's just one component of them that we need to use to make all of these highly accurate predictions, and that is the Coulomb interaction. Now, just so that you guys don't think that Empedocles was so crazy, so you can see that he was actually pretty close. Let's think through the implications of this Coulomb interaction, right? So we can ask ourselves, what would happen, say, here I'll just kind of imagine over here, what would happen if we brought an electron and a second electron together? What would we get? Well, from the Coulomb interaction, we know these are like charges, and so we would get repulsion. Or, the way Empedocles would say it, we get strife. Right? They just don't go together. They hate each other. Similarly, if we bring a positive nucleus, maybe a proton, which would be the hydrogen nucleus or some other heavier nucleus, if we bring two of those together, again, we get strife. They will be repelling each other. The very interesting thing that happens, though, is what happens then if we bring a proton and an electron together, right? We get love. And this works in exactly the same way love works in the actual world. Because what happens when we bring a proton and an electron together? Yes, we find an attraction, but something more than that happens. They combine together. They become one. And out of that comes something that was never there before. A brand new, happy little baby atom is born. It's really quite poetic. The universe is really quite a poetic place, and I think Empedocles gave a great description of that. Now, of course, our method, once we have this basic information, our method is, of course, different, right? We're using the methods of modern science, and in particular, the ingredients that we need to combine here are the laws of quantum mechanics, combined, of course, with the basic data about the particles in our world and how they interact, right? And the other combination, we need a little bit more than just the power of the human mind. We also need to know some fundamental constants to make these highly accurate predictions. But we don't need very many of much of that experimental input. We need to know things like the charge on the electron, the mass of the electron, and the fundamental constant of quantum mechanics, Planck's constant. And the other ingredient we need, because it turns out that particularly when you're dealing with complex atoms and materials, the equations start to get a little bit gnarly. The extra ingredient, which is why this has only recently become possible, is the advent of high-speed computation. So we use large computers to solve all of these gnarly differential equations. So this is why I think it's very exciting to study quantum mechanics, because I want you guys to be able to understand at a very deep level all of the connections and evidence that take us from the world around us to this framework of quantum mechanics, which is then fully capable of making these highly accurate predictions. Right? But I don't want you to understand this at the level of, oh, I just give you the quantum postulates and you then just take my word for it. No, I want you to understand at a visceral level by knowing what were the classic experiments that established this entire framework here, right? How do we know what we know? And I want you guys to be able to understand and experience that as well, so then to have the joy that Empedocles was hoping we would all have of being able to begin with our human mind, some observations about the universe, and then be able to predict very accurately how the material world around us will behave.